Hello, Travis Wayne here once again, and for today's lesson we are going to be learning how to use balance in scales within the science room. Now, in recent years here, our science community has been transferring from the triple beam balances to more digital. And the reason for this is that digital scales are becoming a lot more accurate and there's a lot less user errors involved. So we're going to be looking mostly at our new digital scales that we have here in the science room. But even though we would like to stay with tradition, we are also going to be looking at some of our triple beam balances and how to properly use those. Because in some situations there are no digital scales allowed, so it's good to know the concepts and the ideas behind how to use one of these compared to the digital scale. Now, with a lot of the lessons that we're going to be doing here within the classroom, I would prefer the students be using some of the digital scales. It gives us more precise measurements, there's less user errors, and it's going to have quicker results. So this helps things progress a lot at a quicker rate. But it's still a good concept and a good idea learning how you have to move the triple beam balances to get that accurate reading, because there are still scales here in the United States and within our local areas that still use this as a means of measuring different weights of different items. For example, at our local feed mill that we have, the scale that they still weigh cattle and hogs and goats on still uses this balanced triple beam method, where you slide the weights over and wait for the needle to balance out perfectly even. So it's still a good idea to understand how to use this triple beam balance, even though our society as a general is moving more into a digital era. So first thing we're going to start off with is looking at these triple beam balances, learning how we're going to use these different slides and how we properly identify what the correct weight of the item is. To do so, with me today is we have a kit that has various weights on them. Now, as an instructor, I'm going to be showing you how to identify the certain weights. So these weights here have the weight already registered on them. So this is going to help us identify how to properly slide these things side to side. So we have a good idea that if one of these is going to be 100 grams, well, we should be seeing 100 grams on that triple beam balance, where these go down to 50, 25, so on and so forth. So we're going to have a good idea of how much we should be looking for. So it's going to assist us how to properly use them. So the first thing that we need to look for on a triple beam balance is this is going to have this characteristic where it's going to shift up and down, side to side. So we're going to have to make sure that our needle is perfectly even on our zero here. So looking here, for example, if our needle is up here, we're going to have to calibrate this so it lowers it down so it balances even on the zero. Now, there's multiple ways that you can make sure that your triple beam balance is working properly. The first thing is check your weights or check your slides and make sure they're all the way over to the notches. A lot of the time students will get a little mixed up, a little confused because their balance is not evened out. First thing, check these weights, make sure they're slid over to the side. This is the easiest way to get this recalibrated. Now, next thing, even though some of these are slid all the way over, this might generally not even out at a perfect zero. So there's something else occurring on your triple beam balance. So what could this be? On the far end, behind the plate, you have a silver dial. Now the silver dial can help us tweak that last couple centimeters on that needle. So this is going to assist us to get this calibrated correctly. So if there's any issues with that needle, you can turn it clockwise or counterclockwise depending on which way that needle is pointing to. So right now, after calibration, our needle is at that zero mark, so we're good to go on using this scale. Now the first weight that we're going to use is the 100 gram. So this is going to be an identification weight that we can use to identify. Now we notice on our scale that we have 3 different slides. Now, what are these 3 different slides? The middle slide here goes up by hundreds, so hundreds of grams. So if you have a very large item, it would be a good idea to slide this one over first to get the general weight. The backslide goes up by tens. So this is going to help you narrow in closer to the actual weight. Our last slide that we have up here is the front one, and this goes up by ones. Now each whole number is 1 gram, 2 grams, 3 grams. So it goes up by grams. But we also notice that there's these little notches in between. Each one of those little notches is a milligram. So as a reminder, in the metric system, we work by tens. You move that decimal over, you move on to your next measurement. So if you have 10 milligrams, if you move that decimal point over 1 to the left, you're going to equal 1 gram. So that's how we're going to use that system. So looking on here, we have our hundreds, we have our tens, and we have our ones. So this is going to help us identify this. Now we know, because it's labeled on here, that this is 100 grams. Now looking on here, this middle dial goes up by 100. So we could slide this one over first to identify it. We also notice that the one in the back goes up by tens and bottoms out at 100. So we could use this too. So how you do this, we're going to place this right in the middle to get the best measurement. So now we notice that our needle went all the way up. So now we're going to have to move these slides to get an idea. So start with the largest, work down the smallest. So we're going to start with the largest. So if we move this to 200, we notice it bottoms out. So this is less than 200. So we're going to have to work backwards now. So let's move it to 100. Now this is going to slowly kind of work its way out. And we notice over on our needle here that it's working out to about 0. Now the closer we can get this needle to 0, the more accurate it's going to be. So we can see on the needle that it's just slightly below 0. So there's a chance that this is not a true 100 grams. So we're going to move this back and even out our scale. So let's move our tens now. See if it's a little different. So we know 100 is not going to equal that exact mark. So let's move it back to 90. Well, it's more than 90. So we know it's maybe a tad bit less than 100, but it's more than 90. So this is where this singles come in. So we're going to move and see where we are. So right now we're at about 95.5. So we're going to keep moving this. We're getting a little closer. We're about at 99.4. So we're going to tap it very lightly and try not to disturb the scale. So we're getting closer to that 0 mark here. We're going to tap it just a little more. We're almost there. I apologize if this is taking a long time. I'm looking at the computer trying to read back on the scale as well. So with our final measurement here, we come out to 99.999. It's just a smidgen below that true reading. So it's very close to that 100 gram mark. So this is how you're going to be using this triple beam balance, is you're going to use this measurement of different adjustments. Now, if you have a mystery weight, you're going to still do the same process. Start with the largest one, work down the smallest. All right. Now, with our other type, our digital scale, this is where things come a lot handier. This is where things are going to be a lot more accurate, a lot more quicker. So first, we're going to turn on our scale. Now we notice that there's different readings down below. So we're going to zero this out. Okay, we're perfectly zero. Next thing to do is check the mode. So there's pounds, ounces, grams, things like that. And on the side, we can see these different scale marks. So we want the grams. So we need this little needle, which is at the PCS, to be in the grams mark. So now we're going to be measuring in the metric system because now we're in grams. So we're going to take our weight that we know is 100 grams and place it right in the middle. And here we see that this weight here is 100.1 grams. This is why our society is moving to more of a digital era. This is a lot more accurate. It gives us quicker readings, and now we are complete. What took us about 5 minutes to work with the triple beam balance, we did in about 10-15 seconds with a digital scale. So this is why this is a lot more effective now in society. But it's still important to know those concepts with those triple beam balances so we know how to identify those different things. So hopefully you enjoyed this. Hopefully you learned a little bit about how to use the different balances and different collecting methods. If there's any follow-up questions, please feel free to ask me anything. And actually this would be a lesson that we're going to be doing later this year in our science class. And the following activity that we would have with our students is in our lab. We have about 20 stations that have various objects ranging from a pencil to different rocks and different items like that. And so they're going to be walking around using these different methods to calibrate weight and mass. So hopefully this was a educational lesson, and I will see everyone on Sunday up at Bemidji. Have a wonderful day.